Hello everyone. Welcome back to Dr. Liu's VCE Physics channel. Today, let's learn together about the 2019 physics examination. We will focus on questions related to Newtonian mechanics. My explanations may need to be revised. If any teachers, parents, or students find errors, please feel free to provide your guidance. Since this aeroplane is flying in a straight line at a constant speed, the motion of the aeroplane is constant velocity, and acceleration is zero. So, the magnitude of the horizontal force is equal to that of resistance. In a physical course, 3 students discuss the car crashes. On an internet site, they find the following statement: "It happens in a flash, your car goes from driving to impacting. As the vehicle crashes into something, it stops or slows very abruptly, and at the point of impact, the car's structure will bend or break. That crumpling action works to absorb some of the initial crash forces, protecting the passenger compartment to some degree." The students disagree about using the word forces in the statement. That crumpling action works to absorb some of the initial crash forces, protecting the passenger compartment to some degree. They think that the kinetic energy is used to deform the car's structure, so the crumpling action works to absorb some of the initial crash kinetic energy, protecting the passenger compartment to some degree. A proton collides head-on with a stationary alpha particle. After the collision, the alpha particle travels forward, and the proton rebounds. We know that the mass of an alpha particle is 4 times that of a proton. Please calculate the initial speed of the proton. If we set this proton and this alpha particle as a system, external forces on this system are zero if we ignore gravitational forces. So, we use the conservation of momentum to calculate the initial speed of the proton. A platform is put on the 2 springs, and then various masses are placed on the top platform of the spring system. The compression of springs is measured with a ruler. The compression is shown in the table. The data are plotted as a force versus compression graph for the spring system, and the best fit lines are drawn. We find 2 lines. The bottom line is spring A, and the upper line is for springs A and B. The bottom line is spring A, and the upper line is for springs A and B. So, we use the bottom to calculate the spring constant for spring A. The upper line is for springs A and B. The slope of the upper line is the sum of A and B spring constant. We had already calculated the spring A constant in part by, so we subtract spring A constant from the sum of A and B spring constant, and get the answer. The keywords are using the area under the force versus compression. So don't use the spring potential energy equation to calculate the PEA of spring A. To calculate the PEA of spring A, we should extend the line of spring A. This line with the x-axis and vertical line form a triangle. Please find the base and height length and then calculate the triangle's area. The keywords are using the area under the force versus compression. So don't use the spring potential energy equation to calculate the PEA of springs A and B. When the springs are compressed by 80 mm, the area under the curve contains 1 triangle and 1 trapezoid. The PEA of springs A and B are the sum of them. To find the work done compressing spring B alone, subtract the spring A energy from the total energy. The spring A energy is calculated in part C1, and the total energy is calculated in part C2. The single spring, A, could provide suspension for small bumps, while the combined spring system, A plus B, could provide suspension for more severe bumps. In Newtonian mechanics, 2 multiple-choice questions are worth 2 marks, and 2 short-answer questions are worth 21 marks. The overall score for this section is 23 marks. With a total possible score of 130 points, the percentage for this section is 17.7% of the total score. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.